Hi, this is Mr. Max. I'm doing matrices, vectors, and transformations. Um, this is work that you can also find on my Google Classroom. You will see the link below um, the video. Then you click on it, and then you can go and download the question paper and maybe print it out for yourselves. It's actually 3 tests that I'm doing. So the first one is matrices and vectors and transformations, and there will be others, geometry and statistics. Right, so let's go right ahead and make sure, again, as I said, you have your calculator ready and it's in the right mode. And also um, subscribe to the channel, okay? And also click on the bell to get notifications of every time when I upload material. Okay, let's get to it. So they're saying in the first question, draw the image of shape A after a translation by the vector -1, 3. Now remember, translation simply means moving without rotation or resizing it or turning it. So it just moves. So shape A has to move by a translation of -1. That means the horizontal, this one on top is the horizontal and the one under is the y direction. So this is horizontal shift, and this is going to be your vertical shift or translation. So when there is a negative, it means you go to the left, and if the value here is positive, it means that we are going up. Okay, so we're gonna go then -1, each point -1, 3. So if I was to choose this point, I'll go -1, then I go 1, 2, 3 places up, so that point will be here. If I take this point, -1, then 1, 2, 3 up, that point will be all the way up there. The same happens here, -1, then 1, 2, 3, it's always up there. You can actually complete the diagram now. So this is going to be -1, then it's 1, 2, 3, so it's all the way up there. So now you can actually go ahead and you can draw your diagram just to make sure that you have done the correct thing. Okay, so don't resize it, it's just shifting a bit upwards. All right, okay, now something more or less like that. All right, you get the idea. Then that's 2 marks for doing that. Then the next question says we have to draw the image. Remember, this is the image that I drew here, that's the object. You have to draw the image after a rotation of 180 degrees about the point 0, 0, which is also the origin. So the origin is here. Every distance from this origin will be the corresponding distance. It will be like a straight line. So wherever that point is, it needs to be on a straight line on the other one. So how far is it from the origin? It's 2 places to the right, 1 place up. So we can go 2 places to the left, 1 place down. So it's 2 places to the left, 1 place down. So this coordinates will just simply change. Okay. Maybe also something worth noting, but let's just finish what we have. So this is 2, 2. So it's going to be all the way down here. This is 5, 1. So I'm going to have -5, -1. And we go ahead, this is 3, 2. So -3, 2. Okay. So for translation of 180 degrees, the about the origin, the coordinates, they stay the same, but just with different, because remember this is your third quadrant, and in the third quadrant x is negative and y values are also negative. So whatever this coordinate is, let's say this coordinate for example is 2, 1, its rotation about the origin 180 degrees is going to be the same point but just with negative values. So this is like going to be -2, -1. That is the nice thing about rotation about 180 degrees about the origin. Okay, another thing worth knowing also is that once you draw a line through, and let's say like so, and I take corresponding points, I take that point with this point, you'll see that it will be straight line passing at the center of rotation, as you can see there. Okay, right. So I'm just going to clean this up. So that takes care of that second part. Okay. So what they're now asking us to do, if you look through, you are now supposed to describe fully the single transformation that maps shape A onto shape B. Of course, you can see that the shape somehow has been inverted, but you are 100% correct in saying it's enlarged. So it is enlarged. So we'll say enlargement. Okay, that's one mark for saying enlargement. Now we need the scale factor. So if you take the scale factor by how much is it enlarged, well, you can actually, calculate corresponding sides. So for example, this side here is 3 units, and this side here is just 1 unit. So but 3 divided by 1, well, that gives you a scale factor of 3. So I think it's 3 times 9 as large. So scale factor is 3. One more mark. So what we need now is to find the center of enlargement. One of the things you should also know, if the image is upside down like this, or is it inverted, the scale factor is going to be less than 1. So in this particular case, the scale factor must be a negative value. So the scale factor is negative 3. Okay, that's one of the things you should know. The scale factor, if the image is inverted, like you can see this one, it's like upside down from the object. Okay, from the object, it's upside down. Then the scale factor must be negative, right? Then, in order for you to find the center of enlargement, you simply draw straight lines to corresponding sides. So for example, you can go ahead and say, okay, if I take this one here and I join it with that one, if I take, let's say, this one here, let's go again. So you take this and you join it all the way with that, okay? Just use your ruler for that. Even if you were to take this here and you join it with that, okay? All right. Well, I can actually, let me remove that one because it's kind of tricky, because you can see that the center is going to be all the way with where the coordinate is 1, 0. So if I take this one, for example, and I join it with that one, do you see where these lines meet? That's the point 1, 0. So that is the center of enlargement. All right. So you'll be saying the center of enlargement. I'm just going to say so that you can have an idea. The center of enlargement is going to be the point 1, 0. Don't forget that the scale factor here should be negative because the shape is inverted. Okay, 1, 0. Right, that takes care of that question there. So we get to question 2. You have got different matrices, and you're supposed to do some follow-up work on it. So the first thing is you multiply the matrix A, you multiply by the scalar quantity of 4. That simply means every element, okay, every element inside should be multiplied by 4, okay? So that's like 4 times negative 3, 4 times 2, 4 times 1, and 4 times negative 1, okay? Eventually, this gives you negative 12, that gives you 8, that gives you 4, and that gives you negative 4, okay? They say work out if possible. So another thing I will do is I'm going to write down the order of the matrix. So this is a 2 by 2 matrix, né? 2 rows. So you have the row first, and then you have the column. All right. So this is 2 rows and 2 columns. This is 1 row and 2 columns. This is 2 rows and 1 column, and this is also a 2 by 2 matrix. Now, if you look at B and C, whenever you are adding, if you add matrices, you must make sure that they are compatible. What do I mean by that? If you look at the order of this matrix here, because you must now add each element with the corresponding element. So these two matrices are not compatible. The orders are different. You can only add matrices with the same or subtract matrices with the same order. So you can't be doing this one. So this is not possible. Okay, because the orders are different. So you'll be saying the orders are different. Okay, one is, you can see, B is a 1 by 2 matrix, and C is a 2 by 1 matrix. In order for you to be adding and subtracting matrices, they need to be of the same order, same number of rows, the same number of columns. Now, multiplying matrices, of course, you are multiplying matrix A times D. So what you can also know is that matrix D is referred to as the unit matrix. Okay, you can say identity matrix. So this is the identity matrix. Now, why is this identity matrix so important? It's normally denoted by the letter I. Okay, and anything multiplied, so let's say you multiply the identity matrix, in this case this matrix here, where the diagonal has got ones here and the other one is zeros. Can you see that? The leading diagonal, ones. So when you multiply anything by that, you're just going to get that same matrix back. In this case, you multiply, let's just correct that. So that identity matrix, which is the same, let me just say, so this is D, let's write it the way it is there. So this is going to be A times D, right? A times our D is the same as the identity matrix. So we'll get exactly the same matrix back. Okay, so we'll get the same matrix back. So I'll just show you in any case when you do that, so that you can see the answer will be exactly the same. All right, so let's take our matrix A. Our matrix A is -3, 2, 1, and -1. So we have got our matrix here, so that is -3, 2, 1, -1. Okay, should be multiplied by D, which is 1, 0, 0, 1. Now, once you multiply, I hope you still remember how to multiply the matrices. So you take -3 times -1, okay, plus 2 times 0. And then you take the same thing, you say -3 times 0 plus 2 times 1. Then you start 1 times 1, that is 1 times 1, plus -1 times 0, and then you have 1 times 0 plus -1 times 1. Okay, so let's clean that up and see what is it that we are getting. So for the first part, we're going to get -3, okay, because that's nothing. And then this is going to be 2, and this is going to be 1, and this is going to be -1. Do you see that once you multiply the matrix with the identity matrix, this is the identity matrix, you get the same answer back. So we did not put I there. We wanted you to determine or to realize that that is the identity matrix. BA. So BA. So let us first see BA. So B is the matrix. B is the matrix -5, 2. So that's a and let's write C. C is the matrix 5, -2. The order. So this one here is a 1 by 2 matrix, 1 row, 2 columns, and this one here is a 2 by 1, 2 rows, 1 column. Now, is it possible for us to multiply? what is important is that these numbers in the middle, they must be the same. And of course they are the same. So the resultant matrix, what I'm expecting to get is going to be nothing. If you look at the ones on the outside, it's going to be nothing but a 1 by 1 matrix. Okay, so let me just make sure we get that. So this is a 1 by 2 matrix. So it's B. Aha. So I wrote down the wrong one. Is supposed to be matrix A, not matrix C. So let's just get rid of matrix C, and then we'll see what is our resultant. Matrix A, of course, we have it there, was nothing but -3, 2, 1, -1. Okay, and this was a 2 by 2 matrix. Okay, so the numbers in the middle are the same. This one's here, therefore we can multiply, and the resultant matrix, our answer that we'll get will be a 1 by 2. It will be a 1 by 2 matrix. That means 1 row and 2 columns. Okay, so let's go ahead then and multiply. So you're going to multiply, so you're going to multiply -5 times, so I'm going to write it here, so it's -5 times -3 plus, okay, 2 times 1, that is 2 times 1, so that goes, and the next one, maybe I'll change the color so don't get confused. I'll say -5 times 2 over there, plus 2 times -1. Okay, so what is this answer equal to? Well, we have got here, you've got 15 plus 2, that gives you 17. Oh, another comma. It's 17. And then that gives you -10, and this is -2. So -10 plus -2, that gives you -12. And that is the answer. Right, now we have to find the inverse of matrix A. So I'll go ahead and I'll just write my matrix A here again. So matrix A is -3, and you have 1, 2, -1. Okay, so the inverse of this matrix. In order for us to find the inverse of this matrix, I hope you're familiar with the determinant of the matrix. So we need to find the determinant of the matrix, and the determinant of the matrix is simply found by cross multiplying. So we'll be cross multiplying that, and also you'll be multiplying these two. Okay, so if you then go ahead and you cross multiply, so you're going to have -3 times -1, and you subtract 2 times 1. So that is 3. So this is 1. Okay, that is the determinant. Right. So step 2, of course, so you're going to have, so that was, let's say that is step 1. Okay, so step 2, you're going to find what we call find the adjoint of the matrix. Okay, you don't have to worry about the terminology of matrix A. That simply means you are going to take these two and you're going to swap them around. So it's going to be -1 here and -3 here, and these two you're going to change the sign. So this is going to be -2 here, and this one will be -1. All right, so how do you then find the inverse of a matrix? Well, you multiply the determinant, so you say 1 over the determinant, which is just 1, multiplied, okay, so multiplied by, let's say, -1, -2, -1, -3, okay, and you're going to multiply those two together. So the determinant times the adjacent or the adjoint of matrix um, matrix A. Good. So once you are multiplying, okay, you're going to get the same answer, because 1 times that is just going to be -1. 1 times -2 is -2, and 1 times -1 is -1, and 1 times 3 will be -3. The same answer 1 times that. Okay, so that is our answer. Now, in all my previous videos that I have done with regard to calculating the matrix, and I'm not so sure the inverse of a matrix, I'm not so sure if your calculator has that particular function. All right. So if I was to find the matrix, you can see that I go to Shift and I press 4. Let's get again, Shift 4. All right, matrix. Okay, let's go to my mode, and I choose 6 for matrix. And let's say we call it matrix 1, so that can be matrix A, and it's a 2 by 2 matrix, so it's a 2 by 2 matrix. I pick 5. Right, so if I go and plug in the let's just go in and make sure that we have matrix A. If I plug in the elements of matrix A, so here you'll be saying, for example, well, that is -3. You hit enter, then it's 2, enter, then it's 1, enter, and then it's -1, enter. So let's go back to see what is it that we have done. So it's -3, it's 2, it's 1, and this one should be -1, enter. All right, so this is my matrix. This is my matrix A. All right, I can actually clean it because it's there. So if I say shift, or I say matrix, I go back to 6. So I choose my 1, or I can say shift matrix, because I've stored it. Okay, so I choose that to be matrix A. So I'm going to choose 3. And I'm going to multiply that matrix by the inverse. Anything multiplied by the inverse. So you go to this button here. Okay, so we multiply that by the inverse of matrix A inverse. Okay, well, it's going to give me my answer. Oh, okay, matrix A, which was that, times the inverse. No, we are not timesing it with the inverse. We need to find the inverse of the matrix. My goodness. So let's see if we still have our matrix A. So we're going to start over. Matrix A, we are going to find the inverse of that matrix. Okay, there we go. So matrix A, the inverse, you see, is -1, then -2, -1, -3. Okay, I'm not sure if your calculator does this, but of course you need to find the determinant, and from there you find the adjoint of the matrix. That means you swap around the leading diagonal and you change the signs of the second diagonal in order for you to find what the inverse of the matrix is. Now, the inverse is very important because it's also what helps you when you are solving simultaneous equations. All right, for you to find, you need to find the inverse of a matrix. Now, also remember the determinant here. The determinant, it's a number. Okay, it's a number. It can be a negative number, but if it's 0, then the matrix, we call it a singular matrix. And once it's 0, um, the inverse of that matrix will not exist, because you're going to have 1 over 0, and obviously it cannot exist. Okay, so just remember, very important, you need to find the determinant when you find the inverse of a matrix. You also need to find the determinant when you are solving simultaneous equations using matrices. Right, they are saying, why is it not possible to work out C multiplied by D? So C is the matrix 5, comma, -2, and D is the matrix, well, it's the identity matrix. All right, so just go back and make sure that we have the matrices correctly. So you can see C is 5, comma, -2, and D is the identity matrix. Okay, so the order of them matter again. So remember, this is a 0. So when we are writing quickly down the order, so this is a 2 by 1 matrix, 2 rows, and this is a 2 by 2 matrix. Okay, so the columns in C, the columns, I'll write it down. The number of columns in matrix C is not equal. Can you see that? to the number of rows in matrix D. This is 2 columns. Can you see that? I mean, 1 column, and this one has got 2 rows. In order for them to be compatible, it must be the same thing. Okay? When you do this stuff, it should be the same stuff, right? The number of columns and the number of rows. Basically, when you are writing it out like this, the way I did here, these two should be identical. Then it's possible for you to multiply. So in this particular case, you can't multiply. Therefore, we say, therefore, the product of CD is not defined. Okay, right. So that does it for that question. Let's get to question 3. So they're giving us here a vector. Vector is basically a 2 by 1 matrix. They want you to find the magnitude of the vector. So the magnitude of this vector you use Pythagoras, and you say 3 squared plus -5 squared. You hit your calculator, you get that answer, which is about 5,8309 and so on and so on. So 5,832, 3 significant figures. Right, then we have got 2 points that are given here. They say points P and R are marked on the grid. Now we have to draw P to Q. Okay, let's find P to Q. P to Q. So from P to Q, we're going to go 3 places to the right, because you can see this is positive. So that's 1, 2, 3. And then we're going to go 5 places down. So it's 1, 2, 3, 4, 5. So it's going to be all the way down there. Okay, so it's going to be this way. So I'm using the arrow just to indicate so that we can get an idea. Okay. Then they are saying draw the image of, maybe I can label this one here, Q. Draw the image of PQ after a rotation of 90 degrees about R. Okay, so let's see. So 90 degrees, it must make an L. Okay, so I can find P. So P, remember, it makes an L. So from the center, you should have an L. So this is 1, 2, 3. So therefore, it must 1, 2, 3 upwards all the way up to there. 1, 2, 3. 1, 2, 3. So this is the point P dash. And let's see how far Q is. So if I see from here, remember, it has to make an L. So I can go down. Okay, or I can go across like this. Let me go down. So it's 1, 2, 3, 4, 5, 6. So I can't go up, right? It must make an L from here. Okay, so I went down, so I'll go across. It's 1, 2, 3, 4, 5, 6. Okay, and then from where I am, how many units is it? So it was 1, 2, 3, 4, 5, 6, 7. Okay, wait a minute. So it's 1, 2, 3, 4, 5. Okay, that's where I was. So it's 1, 2, 3, 4, 5. So this is where I need to be. And now you can see that I'm very close. Okay, I have my L, but I need to find out how far this is. So it's 1, 2, 3, 4, 5, 6. So from here, I need to go up 6 places. Okay, so it's 1, 2, 3, 4, 5, 6. So that's like 13, 14 if you look at the coordinates. So that will be my Q dash. All right, so if I was then to draw that, that is how it's going to be. Okay, so every point should make exactly an L 90 degrees in that direction. Okay, so when you look at where this point is, it makes an L with regard to that point where you are. Okay, can you see the L going from there to there? Okay, or from here to here. Am I right? R all the way up here. R up to here. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So 6 across. Let's hope it's 6 places. 1, 2, 3, 4, 5, 6. Correct. Okay, so we have labeled it. So we have P dash, Q dash. You can also work with the coordinates in order for you to find those missing places or the points. Right, the next question, they give us part C. they say DE is given by 2A plus B, and DC is given by 3B minus A. So maybe we can go ahead and maybe, or let's use the arrow. Well, let's say that will be D to E. Let's say that will be D to C, wherever it is. And let's say maybe that will be, so tail to head and stuff like that. So maybe if I was to label it, so this will be D, this will be E, and this will be C. So D to E is 3A, no, 2 is 2A plus B. Okay, you can draw lines like that because it should be bolded. This is 3B minus A. So in order for us to find C to E in our diagram, vector CE is the same as going CD plus DE. But CD, you're going against this vector, so that will be minus whatever vector DC is, plus DE. So let's just write down what we have. So that's going to be negative, and D to C is 2A plus B, plus DE, which is DC. Okay, so a little bit of an error there. So D to C, remember, it's 3B minus A, and DE is nothing but 2A plus B. Alright, so it's just a matter now of removing the brackets. Here is minus 3B plus A plus 2A plus B. Of course, you're going to have 3A if you add minus B, and that is the answer. Right, they are saying you are given here position vectors. So this anything that starts from the origin, they are called position vectors. Okay, starting from the origin. So when you are now you're given a displacement vector like TV, we call it a displacement. TV is a displacement vector. How do we calculate TV? Well, you take the second point of the position vector. In this case, you say OV, always minus with the first point of the position vector, OT. This is like the general formula or way that you calculate it. So in this particular case, OV is given as 5, 5, negative 1, minus OT, which is negative 2, 5. So you can just go ahead and subtract each of the elements from each other. So negative 1 minus 5. Okay. And then that will give you, so remember, just close it. So that one on top will give you 7, and that one gives you negative 6. So you get a mark for each of the correct elements. Right, E. Well, they say find CB in terms of, okay, so let's just write down what we have. So they say MX, or they are saying that CB we are supposed to find CB, so C to B. So, but we know that AB, this one all the way, that is going to be B. Okay, and AC, so A to C, there's one here, that is C. Okay. So once we find CB, CB will be minus C because we're going against that, plus B. I'm just going to write it as B minus C. See that? Right. Another thing that we know, and I'm just going to take this off so I can create some space. We know that from our information here, X divides CB, this whole CB, in the ratio 1:3. So that is 1, and that's 3. So that's 1 over 4 and 3 over 4 parts, because if you add 1 plus 3, you get 4. Okay? So whatever CB is, if you have to find CX, it will be 1/4 of CB, if that was the question. What we also know is that M is the midpoint of AB. So this is going to be a half of B. Even this one is a half of B, because that's like half of AB. Now they are saying we're supposed to find MX in terms of B and C. So I'm going to write down a few things. So first of all, let's write down what is MB. Right, MB we know is a half of B, okay, from our diagram. Something else, what is XB? X to B, can you see that? So X to B is 3/4 of CB, okay? And what was CB? Well, it's our answer in Roman 1. So this is 3/4 of B minus C, okay? So if I clean this up, I'm going to get 3/4 of B minus 3/4 of C. All right. Now, what is the next thing that I need to know? What is BX now? Okay, so we go back to our diagram. B to X, this whole distance BX. So that's going to be negative, okay, whatever my answer in my previous answer is, negative. So that would be negative. What was my answer? The one that I previously did? Negative XB. Negative XB. So that's going to be negative, and we had 3/4 of B minus 3/4 of C. Okay, that is 3/4 of B minus 3/4 of C. Right, if I clean this up, I'm going to get 3/4 of C positive minus 3/4 of B. All right, so that's B to X. Now that I have all of that, how will I find MX? Well, M to X, which is what I am required to find, MX is going to be, so I'm going from M to X, so I'm going to MB plus BX, okay? That is going to be equal to MB, that's MB plus BX. So let's just now write in the stuff that we have. We know that MB from our previous answer is a half of B. We know that BX is the one that I have up here. That's 3/4C minus 3/4B. All right, so when you do the B's, or this is going to remain 3/4C. When you say a half minus 3/4, that's going to give you minus a half. Okay, it's going to give you a half minus 3/4 is going to give you minus a half B. Okay, it's like 2/4. Do I have it correctly? I have a half minus 3. So let's make sure that we get the correct answer. A half minus 3/4. Negative 1/4. Okay, so a half MB minus that, so that's negative 1/4. Right, so as the way you solve that, you should get definitely to the same answer. So it doesn't matter if someone else wanted to take a different route, for example, you start anywhere, but it will take you a bit longer. Maybe it's like a long way to get to that. You're going to get the same result. And so someone could have gone MA plus AC plus CX, and you'll still get to the same answer. All right, that does it for this test. Good luck with your exams, and stand by for the next tests. Also, maybe you need to remember that you can download, you go obviously say to Google, and you find this app here, Classroom, or you can download it on your phone or any device. Classroom, Google Classroom, and then you can try to join my classes. So I'm going to put this in grade 11 and also in grade 10, and you will see under my classwork that I've included this, so you can actually click on this, all right, or you can click on that. It takes you to the document that I have. I said use this test for revision purposes and check out the solutions. So you can go into the document, and you can print it out if you have a printer at home, okay, and then you find a copy of the test. All right, this is not just one test. There are two more tests that I'm going to do. I put them all in the same document. The second test is geometry and measures and mensuration. So if you go through it, you will also see about 30 marks worth of question on the same thing, okay, and then you can try to attempt to solve that, or you follow what I do. And the next or the last test is probability and statistics, okay, and then you also scroll down and then you see. So you print this thing out as a document, okay, and then you'll be able to see or download it in order for you to be able to work out through this yourselves, or you can follow and see what I do. All right, so you join my classes in, I put a link up for you, takes you directly to that. But if you want to join my classes, the class code, and this is where you need to write it down, okay. um, the class code to join these classes is given here. So it's MYA3DUO, okay, and this is for you to join my classes. You say join classes, and it will take you to grade 11. So you'll also see that there are plenty of other work that I have, some question papers and memos, paper 2 extended with memos that I've worked out, a lot of work that I've put, algebras, tests I gave to my students on Venn diagrams, during the lockdowns. Paper 2 and 4 of 2019, you'll find these, you're going to find the question papers, grade 11 for 2020. All these question papers are also worked out, and you'll find them in, so say for example, you're looking for 2020's question papers, all right? Let's say you want to do paper 1 because you want to prepare for the exam, right? So you go to paper 1, and you will see that paper 1 is there, all right, and then you can go ahead and check paper 1 on my YouTube channel. So you go under question papers. There's a playlist for question papers, and you'll find this question paper, and you'll see that it's fully worked out. Okay,